welcome to my YouTube channel, Your Average Coder. This is your host Pratik Nandani, and today in this video we will learn about arrays and linked list. So first let us take a look at what are arrays. Arrays are defined as the collection of similar type of data items stored at contiguous memory locations. Actually, arrays are the derived data types in C programming language. Array is the simplest data structure where each element can be randomly accessed by using its index number. Now let us take a look at need of using arrays. In computer programming, the most of the cases requires to store the large number of data of similar type. To store such amount of data, we need to define a large number of variables. It would be very difficult to remember names of all the variables while writing the programs. Instead of naming all the variables with a different name, it is better to define an array and store all the elements into int. Following example illustrates how array can be useful in writing code for a particular problem. The first one is a program without array, in which we can see there are many different variables, so we need to remember all the variable names. The second is the program by using arrays, in which we can store all the marks in a single array. Now let us take a look at advantages of array. Array provides a single name for the group of variables as we saw in the previous example. Traversing or going through an array is a very simple process. Any element in an array can be directly accessed by using the index number. So now let us take a look at memory locations of the array. As we have mentioned, all the data elements of an array are stored at contiguous locations in the main memory. The name of the array represents the base address or the address of first element in the main memory. Each element of the array is represented by a proper indexing. The indexing of the array can be defined in three ways. The first one being zero-based indexing. In this, the first element of the array will be at the zeroth index. Second one being one-based index. In this, the first element of the array will be at the first index, and the last one being n-based indexing. In this, the first element of the array can reside at any random number index. Now let us take a look at accessing elements of an array. To access any random element of an array, we need the following information. First is the base address of the array. Second is size of an element in the bytes. And third is which type of indexing the array follows. Address of any element of a 1D array can be calculated by using the following formula. Byte address of element A of I equals to base address plus size into I minus first index. Now let us take a look at linked list. Linked list can be defined as collection of objects called nodes that are randomly stored in the memory. A node contains two fields. The last of the node of the list contains pointer to the null. Here we can see how the linked lists are. Now let us take a look of the uses of linked list. The list is not required to be contiguously present in the memory as arrays. The node can reside anywhere in the memory and link together to make a list. This achieves optimized utilization of space. List size is limited to the memory size and doesn't need to be declared in advance as arrays. Empty node cannot be present in the linked list. We can store values of primitive types or objects in the singly linked list. So why use linked list over array? Linked list is a data structure which can overcome all the limitations of array as we previously saw. First is it allocates the memory dynamically. The nodes of linked list are not contiguously stored. Second is sizing is no longer a problem since we do not need to define its size at the time of declaration like array. List grows as per the program's demand and limited to the available memory space. Now let us look at the different types of linked list. The first one is singly linked list or one-way chain. Singly linked list can be defined as the collection of ordered set of elements. One-way chain or singly linked list can be traversed only in one direction. In other words, we can say that each node contains only next pointer. Therefore, we cannot traverse the list in the reverse direction. The photo here shows how the singly linked list works. Second is doubly linked list. Doubly linked list is a complex type of linked list in which a node contains a pointer to the previous as well as the next node in the sequence. A doubly linked list contains three nodes having number from 1 to 3 in their data part is shown in the following image. The third is circular singly linked list. In a circular singly linked list, the last node of the list contains a pointer to the first node of the list. We traverse a circular singly linked list until we reach the same node where we started. The below photos explains how circular singly linked list works. The last one is circular doubly linked list. Circular doubly linked list is a more complex type of data structure in which a node contains pointers to its previous node as well as the next node. The last node of the list contains the address of the first node of the list. The first node of the list also contains address to the last node of its previous pointer. Here is a photo to clarify how a circular doubly linked list works. Thank you for your attention.